Spice math. That's right. You add it up, multiply it, man. Spice math. Okay. A couple things we're gonna learn today. Spice math. All right. Take some time, educate yourself. Spice math. That's right. You won't believe it's just math. Come on.
Hi, I'm Ruth Doughton.
Hi, I'm Erin Williams.
Hi, I'm Brandon Alexander.
Hi, I'm Kelvin Doughton.
Hello, I'm Lyndon Sincere.
We are your Spice Math tutors.
You won't believe it's just math. Just math.
Hey Math Warriors, welcome to another episode of Spice Math. I am Marvin Phillip, your Spice Math tutor for today. Today's lesson, we'll be focusing on sequence of numbers. This lesson is targeted towards students from Forms 1 right up to students in Form 5. The objectives for today are for you, the Math Warriors, to be able to define a sequence of numbers, to define natural, even, and odd numbers, to identify patterns in sequences of numbers, and to use these patterns to determine subsequent terms. What you need to know before we start today. First of all, you need to know what are natural numbers. And natural numbers are whole numbers from 1. We also define natural numbers as counting numbers. If I ask you to count to any given number, you would start with 1, then 2, 3, until you get to that number that I asked you to count to. That is what we call natural numbers. Secondly, we need to know what are even numbers. And even numbers are numbers that can be exactly divided by 2. Examples of even numbers are 2, 4, 6, 8. Now, if we divide any of these numbers by 2, it gives us an exact value. For instance, 2 divided by 2 is 1, 4 divided by 2 is 2, 6 divided by 2 is 3, and 8 divided by 2 is 4. However, odd numbers cannot be exactly divided by 2, meaning that we would always get a remainder. Example, 3, 5, 7. If I divide 3 by 2, it gives me a remainder of 1. If I divide 5 by 2, it gives me a remainder of 1. If I divide 7 by 2, it gives me a remainder of 1. The common factor here is that all numbers, all odd numbers, when divided by 2, gives us a remainder of 1. Now that we've got that covered, let's get to the source. First of all, we have to be able to define what a sequence of numbers are. And a sequence of numbers is a list of numbers that follow a mathematical rule or pattern. The big question here, the question that you have to always ask yourself, what is the pattern? Or what is the mathematical rule? For today, we would focus on sequence of numbers that have a common difference, as seen here, and a common ratio. Let us understand what I mean by common difference and common ratio. For me to go from 1 to 3, I realize I need to add 2 to 1. That's how I get 3. And then to go from 3 to 5, I need to add 2. To go from 5 to 7, I need to add 2. What we realize, the common difference here is 2. So in order for me to get the next 2 terms in the sequence, to the 7, I would have to add 2, which would give me 9. And to the 9, I'd have to add 2 again, which gives me 11. Now, if I look at the common ratio, however, instead of addition or subtraction, we're looking at the numbers either being multiplied or divided by the same value. So here, in order for me to go from 1 to 2, some persons may think, let us try finding a difference. The difference between 1 and 2 is 1. If I add 1 here, now I have to add, to get 4, I have to add 2 to it. Right? So in this case, we don't have the common difference, but we could find a common ratio. To go from 1 to 2, I can multiply 1 by 2, that gives me 2. And then I can multiply 2 by 2, which gives me 4. Multiply 4 by 2, which gives me 8. So to get the next two terms, I'll multiply 8 by 2, which gives me 16, and multiply 16 by 2, which gives me 32. Now let's try these sequences. Can you find the next two terms in these sequences? Let's try them. First of all, I have the numbers 1, 2, 3, and 4. And I want to determine the next two terms in the sequence. Let's look and see. Do we have a common difference here? To go from 1 to 2, I have to add 1. To go from 2 to 3, I have to again add 1. To go from 3 to 4, I am adding 1. Therefore, to go from 4 to the next term, I have to add 1, which will give me 5. And then to go from 5 to the next term, I add 1, which gives me 6. So the common difference is 1. The second example. Now, what I don't want you to do is to limit yourself to thinking that questions only have one specific pattern. Sometimes the pattern in the question may vary, but it's up to you to be observant and to identify what the pattern really is. As in example 2. Now, if I am to go from 9 to 8, I would have to subtract 1. But then to go from 8 to 10, I can't subtract 1. If I subtract 1, I'll get 7. But I'll have to add 2. It's important for us to test the patterns that we are observing with all the terms given. So let's continue to test. Now, in order for me to go from 10 to 9, I would then have to subtract 1. And then to go from 9 to 11, again, I have to add 2. So now we identify that our pattern is not just the difference of 1. My pattern is to first subtract 1 and then add 2. And this pattern fits throughout this sequence. 9 minus 1 is 8. 8 plus 2 is 10. 10 minus 1 is 9. 9 plus 2 is 11. So based on that pattern, what do I do next? I will now have to subtract 1 from 11 to get 10. And then I'll have to add 2 to 10 to get the next term, which is 12. The third example. I have 3, 15, 75. What are the next three terms? Two terms. In order for me to go from 3 to 15, I realize I have to multiply by 5. Then to go from 15 to 75, 15 times 5, yes, it does give me 75. So I realize that now I have a common ratio which is 5. So to get the next term, I'll have to multiply 75 by 5. It's a little difficult to do it mentally, but let's try it out. If you have your calculators, by all means. 5 times 5 is 25, 5 sevens, 35, 5 times 350 plus 70 plus 25. So that will give us 375. Now, to get the next term, I will have to again multiply by 5, which is another big one. Mentally, let's try it out. I don't want to say it out loud. I'm doing it in my head. You could try as well. I think that gives us 1,875. Correct me if I'm wrong. Right? So I realized that to get the next two terms, I had to multiply by the common ratio, which is 5. Final example. I have 162, 54, 18. And I want to determine what are the next two terms in the sequence. Now, let's test and see what must I do to go from 162 to 54. Now, for me to go from 162 to 54, I realize I would have to either divide by 3, or you can see it as multiplying by 1/3. Right? So if I divide 162 by 3, it gives me 54. And then divide 54 by 3, it gives me 18. 18 divided by 3 gives me 6. And 6 divided by 3 gives me 2. I identify here that my common ratio is 1/3. So for those of you who may be a bit confused, you notice that I divided by 3, but I wrote the ratio as 1/3. Do you know that A divided by 3 is equal to A multiplied by 1/3? If we remember division of fractions, we will note that 3 can be written as fraction 3/1. When we are called to divide by a fraction, what we do is to flip the second fraction and multiply, which shows that dividing by 3 is the same thing as multiplying by 1/3. So now it's time for you to do it on your own. Try these out. So how did you do? Did you find the next two terms for each of the sequences? Compare your solution with mine. Are we on the same page? If so, again, tell your parents to make you your favorite meal for dinner tonight. Thank you for tuning in to this episode of Spice Math. See you next time.